Hey Techno Studs! In our Network Fundamentals course, we talked about private addressing, or RFC 1918. So let's just do a quick refresher on what that private addressing was. One thing that I find helpful as I'm studying some of these concepts is to take a look at the history. Sometimes by taking a look at the history, we can better understand why it developed the way it did and where we're at right now. So that's what we're going to do. We're first of all going to take a look at the history of IPv4 and IPv6. So let's take a look at some IP milestones. Then what we're going to do is we're going to get into RFC 1918 and specifically the ranges, what we've set aside to be private addressing. And then finally, we're going to end things with talking about NAT and how NAT is a solution, network address translation is a solution with these private addresses and public addresses. So here's where I see several milestones when it comes to IP. What we've done is we created this initial, how do we address different computers on the network? And then we've had to say, well, that model doesn't quite work. We're going to have to make all these adjustments along the way. So what were some of those adjustments? Well, in 1980, RFC 760 defined what IPv4 looked like, what an IP address looked like, and when the original IP address, it was just the first 8 bits of that represented the network. Well, it became very clear, because that only provides us 256 networks, it became very clear that that wasn't going to cut it, that we needed more networks than that. So in 1981, there was RFC 791, and it created the idea of classes, or we call that classful. So this idea of classes segmented things out. So we had a block of class A addresses, which there's only a few networks with that, but it had a lot of hosts for each one of those networks. And class B had a lot more networks, but then had not quite as many hosts. And then a class C had quite a few more networks, a lot of networks, and not very many hosts per network. And so we ended up expanding this and having up to, or quite a bit past, 2 million networks at that point in time. So then in 1985, RFC 950, we were once again running out of these networks. We needed more networks. So it created this concept of subnetting. It said, well, we're going to, within a class A, we have way too many hosts, and we want to break that apart into smaller segments. So we are going to subnet it. So even though it's a class A, we're going to break it apart into smaller networks. So that's the idea of subnetting, is to break it apart into smaller networks. Then we get in 1985, we've got actually quite a few RFCs come out, and a couple of those that's noteworthy is 1817 and 1878, which defines CIDR notation, VLSM, classless. There's a few of them that kind of all made some changes within here around the same time. But what the idea behind this is, not only can we subnet, if we have a 10.0.0.0, not only can we break them down into different subnets, but those subnets can actually be different sizes, or we call that variable length subnet masking, or VLSM. So that's where the VLSM came around. In 1996, we still see that there's a lack of IPv4 addresses. So we got to come up with another idea, and at that point in time, we came out with RFC 1918. The idea behind this is they defined some private addressing that wouldn't be routed on the internet, and this private addressing then can be translated to a few public addresses. So many private addresses could be translated just to a couple public addresses, and therefore we could that public address could represent many different private addresses. And the advantages to this is then it greatly increased the amount of networks that we could have, while while still maintaining this IP version 4, being able to use IP version 4. So really, all of these manipulations that came were changes to the IP version 4 to push it along further. And at some point in time, we just realized, well, we need just way more addresses, and everything is becoming addressable and has some sort of network address on it. So then that's when we came out with IP version 6, which drastically, we go from 32 bits to 128 bits, which makes that address space so incredibly large that it will last us for a long time. And that's RFC 2460. That was one of the first ones to define IP version 6. So what are these private addresses? Well, first of all, the private address ranges are defined by this RFC 1918. And so what they've done is they've said, okay, well, let's choose a class A, a class B, and a class C. Let's choose a range within there and define them as being private addresses. So that way there's some variety with what people can choose for their networks. And having some of that variety is important because I have large networks that I'm going to want to be able to address, and then I also have very small networks that I want to be able to address. So what are they? Well, they chose this range for class A, which consists of a 10.0.0.0/8, which gives us a range from 10.0.0.0 to 10.255.255.255. And this just gives us one network here, but 16 million hosts. Like I said, we can break that down though into smaller so we can create more networks out of that and have less hosts per network, which makes a lot of sense. A lot of corporations and enterprises, large networks will use this 10 range, and even a lot of small networks will use this range as well because it gives us a lot of variety. Why not just choose the 10 range so you can add a lot of variety? So then we have this class B range, and this class B range is 172.16.0.0/12. which makes the range, I got it right here, 172.16.0.0 to 172.31.255.255. Gives us 16 networks to work with, and 65,536 hosts per network, although once again, we can break that down so we can create more networks and less hosts per network. Then we have the class C range, which gives us 192.168.0.0/16, which the range is 192.168.0.0 to 192.168.255.255. That gives us 256 networks that we have to work with 256 hosts per network. Although once again, we can actually break this down further so we have more networks and less hosts per network. So that is the private addressing ranges. So how would we use that? Well, here I have our network that we've been working with, and let's say I wanted to connect this to the internet, which we will be doing within these series of videos. So the internet is often shown as a cloud, and I want to connect to the internet. And so what will happen is as my addresses or as my traffic goes outside of this network, it takes on one of the public addresses. So a public addressable would be maybe like 181.41.162.3. Let's say that's the address right there. And so what happens is that whatever's trying to reach out, like let's say it's this laptop, gets translated as it goes outside this router 2 to this address right here. And same thing with maybe some of these other devices as well, gets translated through this one IP address. That IP address is addressable to the outside world. So any traffic that's outside of in the internet will know how to get back to this public address, where they wouldn't know how to get back to these private addresses, that those are unroutable on the on the public network. So it comes back to this, and then it gets translated back to get sent to the proper machine. So that's network address translation. We're able to have one IP address represent many different IP addresses on the back end. So that would be NAT. So there you have it. It's helpful to take a look at the history and see where we've come. There's quite a few times where we ran out of the number of networks or the number of IP addresses that we need, and we've created ways to compensate for that. One of those ways that we've created is this idea of private and public addresses, and we use NAT, or network address translation, to translate between those private addresses and those public addresses.